Well, we're going to start. Good morning, everybody. I hope sound is clear. People are still entering. Let's see. So we're going to talk today about how to connect AutoCAD Civil 3D projects with Revit, and that way create BIM assets that we can use not only with InfraWorks, but export to navies, glue, all the kind of things we need to do nowadays, right? So let's see if this works. Where is my mouse? Okay, this is subject, BIM for infrastructures. And this is the class summary, how to get the information model from your model and push it around the project tools that we use nowadays, and that better collaboration. So we're going to try to explain how to prepare AutoCAD Civil 3D elements and create this way BIM assets, how to use these objects to empower our Revit project. And of course, we're going to use a federated model. Maybe we have no time to show in Navisworks, but for sure we're going to show in InfraWorks. And we're going to show good parts of how InfraWorks is going to be part of our workflow here. Okay, Lucy, it's for you.
So I work with Fernando, and we're in premium support, and we work as designated support specialists. And we sit next to each other in the office with our fine colleague, Nate Moore, and so we have access to all these tools, and we see how these tools, when I'm a civil engineer and I'm trying to do something in Revit, we see some of the pitfalls. So we have to really put this class together so that we can tell you up front about some of these pitfalls. You're not going to learn how to do civil 3D today. You're not going to learn how to do Revit today, but hopefully you're going to take away some nuggets on how you can get and be successful with bringing the coordinate systems together. So let's first talk about horizontal and vertical projects, or horizontal and vertical BIM. If I have a route, a corridor, a pathway, anything that's long and linear, that meanders both horizontally and vertically, that is horizontal BIM, horizontal projects. We do those mostly in what? Civil 3D. So then we have vertical BIM, which are structures. Structures can be something as tiny as a house, a shed. They can be tunnels. They can be bridges. They can be these punctual points, these areas where we have vertical projects. So our goal is to get those tied together. So as we look at the next video, I want you to think about horizontal and vertical projects, and I want you to ask your question. Ask the questions that I put on the slide about what types of infrastructure they are, what can this BIM example be used for, and what are the pieces and parts? Okay, when I say pieces and parts, we're talking about BIM digital assets, right? Digital assets. And let's take a look at that video. And it should launch by itself. There we go. And it should go by itself. All right, so horizontal or vertical? Horizontal. So if this was a BIM presentation, what would this be used for maybe? Planning, thank you very much. Okay, and I'm not going to be staking out the curves and the cant and all that from this. So next, so the project that we're going to work and show you as our example, as our data set, we're going to use the KISS principle. I think you all know what the KISS principle is. Keep it simple, silly, okay? And that's because if we can use big, huge, impressive, cool stuff, but we're going to do it keeping it simple. So then, if you take the data set, it'll happen fast. So it's a small development. It's a residential development project, and we're going to highlight this connection between the civil engineering, doing the site grading, doing an alignment with the vertical and parking, underground parking, all that. Now the fundamentals that I want you to take away are the McLamy principle, and I think you've all heard of the McLamy curve. Okay, we're going to demonstrate why that's important. And also, I think the most important thing that Fernando and I come across is the geospatial coordinate systems, correct? And how we get the things to work tightly together. So we're going to do a lot of our civil and Revit interoperability using solids. Why do I want to use solids? Anyone know? They're ubiquitous. I can attribute the living daylight out of them, and I can use them in how many applications? Everything, okay? All right. So now we're going to study this really hard. So this is a process plan, and we're just going to step through. I have listed over here on the side the 6 phases, and we're literally going to start and just show you examples coming from left to right across this. Okay? And we're going to start first with the conception. And we're going to start, we've got 2 ways that we can start. In the modern way, we can start in a real world context. This is the new way of doing it. What am I going to do? I'm going to start sketching and laying out in which tool? Which tool? InfraWorks, okay. Where are my prizes? But however, we still have to live in the traditional world where many times we get that project sketched on the back of a napkin, on a PDF, whatever, okay? So we're going to show you the start of both of these. And thus, we're going to go way over here on the left-hand side and getting our project started in 2 ways, the traditional way and with the new contextual real-world way. Okay, now, before we get started, we need to know how we're going to tie our vertical infrastructure to our base map and our base plan. And so we have decided that this is going to be our common point. In Revit, that common point is going to be called what? The survey point. Okay, very good. That's going to be our point of reference, and you're going to see how we're going to carry that point of reference throughout this modeling.
Your slides are not running.
Okay, so
They're not moving. Let's check, yes.
okay, he's going to try to get the video to go. If I want to take, in 2018, AutoCAD 2018, there is a new ability to extract vectors from PDFs. Who knows about that? Okay, so this video, long story short, we're going to extract the vectors out of that PDF that we got from the project leader. We're going to take that and we're going to turn that PDF and the extracted vectors into a true geo-referenced system. Okay, what command in AutoCAD am I going to do that with? Okay, rubber sheet, okay, but even more simple. Align, the good old align command. So we can do it either visually or we can do it more precisely with survey control. All right, and you noticed on the, we're not going to get the video.
No, the videos
are
are not possible.
Okay, let's go to the next one.
Let me check if I can go. Okay. Oh, okay.
So, see if you can. Oh well.
Yep.
Okay.
Anyhow, the video is going to be available, so you can download them. Yeah, it's not. They don't run here.
Yeah, let's go to the next slide,
Yeah.
and then while you're talking, I'll pull out
Yeah.
my computer. All right. So now that is the traditional way. Now I mentioned that there's this new way, the new fun way, and that's to actually do this laying out and planning in a real-world context. So that, of course, is InfraWorks. And we have the model builder utility in InfraWorks. Who's used it? Like, oh, really? I was expecting 99.9% of you have used Model Builder. So Model Builder is free with your Autodesk account. I don't think our video is going to show this, but we have to, we're able to go on the map of the entire world, and you're able to block out an area visually, or if you do have real coordinates, you can get those in vis-a-vis a shape file as the limits. And in Model Builder, it's going to go and create a base map for you. And that base map is going to have a little bit of terrain. It's going to maybe have some buildings. It's going to have the aerial imagery. And if you're doing something maybe way north, Nate can probably tell us where you might not get the aerial imagery. But for most of your work, you're going to get some aerial imagery. The caution is that this is, you have to understand LOD and LOI. What's LOD? Okay, level of detail, level of development. I've heard it called several things, but basically the level of development. LOI. Yeah, level of information. So remember, when you get these base maps, that you are at a very early stage of LOD. Okay, LOD 0.5 or something, okay? So, but it's a great way to get started. And then with the sketching tools that we can use, you can, instead of sketching on a napkin or on a map, you're going to sketch in real world context. It's definitely not. Okay. Next slide.
Okay.
All right, so that's what you get. Okay, this is a base map. Now that's pretty darn good. You know, that's not bad. Our residential development is that tiny road above the treatment plant, the water treatment plant. And next slide.
Oh, come on. Yeah, I think I'm gonna try. Well, I'm gonna jump to the next slide, and then I'm gonna remove this from slideshow. Okay, let's see if it goes this way.
And there we have the landscape feature at the entry to our. All right, okay, remember I told you we're not going to teach you how to do Civil 3D. We're not going to teach you how to do InfraWorks, but we want to teach you about some pitfalls. Fernando, Nate, and I see this pitfall happen time and time again, and this is surface management within your model. Whether that model is an InfraWorks planning model, or more seriously in Civil 3D. The advent of scanning, drones, and more data than we can ever imagine is leading to these problems. Okay, what's the largest size in point number that a Civil 3D surface should be? What's the maximum? Oh, come on. Civil 3D Jeopardy. The maximum number of points in a Civil 3D surface. 2 million. Okay, so when you start to get more than 2 million points, it actually starts happening at like 1.8. It caches out, and you can have huge surfaces. It just caches out to a memory mapped surface file, and you want to kind of avoid those at all costs. All right, so we can add additional things to our base map. Okay, so SketchUp, we can get that content in there. Drawings, 3D drawings. And we can put in CSVs. So here we have CSVs points as trees. And the attribution on the trees not only gives us the size of the tree, but also gives us the types of the tree. And we can make that magic in InfraWorks and make the trees come in with the proper type and the proper size. So this is an important thing to know to add to your InfraWorks. And that's not going to work. Okay. So next slide. GIS information. GIS is going to become especially after the announcement yesterday with Esri, right? We're going to be we already can leverage a lot of GIS data, but typically GIS data we know is 2D. But we can extract attribution that gives us 3D. So here we have a pipe network that is in shapefile format, but when we bring it into Civil 3D or InfraWorks, it comes in at the right elevations. So 3D from GIS is another one of these ways that we refine the base map. All right, leveraging paper data. This is my favorite because, again, this goes back to the AutoCAD align command, where we can take and we can extract using raster design or trace over or that PDF trick, and we can bring that legacy stuff into the real world with the align command, doing visual recognition or point to point if you actually have the ability to see survey points, and then extrude it out in 3D and you've got it. All right, now here is the critical part, the split between horizontal and vertical infrastructure. This is the division point where the McClamey principle comes in. This is the point where we have to decide how we're going to tie both of these systems together. So the yellow dot represents, in our simple project, represents this base point that you're going to see used over and over again as a 3D object that is going to hold that yellow dot so that we can tie anything from the different specialties back to that point. And so they all come together. All right, so the split now is going in a parallel work stream with the civil people working and the architectural people working. So we don't have to work, let's go to the next slide and look at the McClamey principle. That's the McClamey curve, that's BIM 101. And basically what we want to do is we want to have multiple disciplines working at the same time. And this is a dashboard. This is a BIM dashboard, and it's a 5D BIM dashboard. So we know what 3D is. What's 4D? Time. What's 5D? Cost. So this is a 5D dashboard. Now, the way that this works is that we start to split out the disciplines so that the bridge designers are working at the same time as the civil engineers are doing the grading and the abutment work and all that. And because of our dynamic objects, and again, another principle of BIM, we can be successful in running these things in parallel. We know when we run them in parallel stacked like this, the time gets shrunk because we're not going 1, 1, 1. So I can send the surveyors out to get more information. I can send the geotechnical people out, but my structural bridge people are not going to be stopping and waiting because they know that they can feed that information back in and keep running. So collaboration is essential for this. So in Civil 3D, we can leverage the power of corridor modeling, and we can do it for more than just making a path. In this particular case, this corridor model, and the reason I want to use a corridor model is because it's extremely flexible and very, very dynamic. And it has built-in conditionals and also built-in attribution that allows us to do things like quantification and materials and things like that. So we're not only doing the road center, but we're also going to grade out the lots, the building lots, the building pads. And then we're also going to put in the retaining wall, and then we're going to hit a piling, a metal sheet piling that goes along the river edge. Okay, one thing does it all very dynamically. And there we have the components, so the horizontal layout, the profile, and the development of that. Next.
I was looking for the video, but I have videos here, but I don't play. Come on.
So that's going to be the end result there. And the corridor, you can see that I have pulled out unique materials based on the names of the links, the purpose of the links. And with that, we can, have these properties, then we can do materials quantification, and then I can start sending this information to the Revit people so that they can start looking at datum surfaces, getting floor heights, finished floor heights, and things like that. And darn it, I wanted you to see this one. Maybe
Is
I'll
material- I
try to
gotta
get
look
it
for it,
going.
yeah.
Because one of the cool things, talk about future of making things. One of the cool things and future of making things is machine controlled grading. And so what can you do with datum surfaces pulled off of that assembly? You can upload it to a grading machine. And I've got a little tiny video of that. But hopefully if we can get that going, we'll show that to you. But that's a side benefit. All right, and then see, we worked our way from left to right across this, the composition, across our process chart, and now we're kind of at the end. And the federated model, once we start to compose this model, then we can leverage it for lots of BIM tasks. We're not here to show you those BIM tasks, but what are some BIM tasks that are typical that you would do with the model? Clash detection is probably the first one that comes to mind. Quantification, what else? So virtual construction, timelining, things like that, okay? So just to be aware that that is the output end of this, okay? And I believe now, Fernando, you get to talk yours, and maybe I can get my computer fired up.
See if you can find the models. So, as Lucy said, she's developing a lot of information in Civil 3D, and we want to use it, more wide broad it, in Revit or InfraWorks as solid objects or in Navis, so on. So our solution here came from this data that she's creating, and we're going to show the process to interact with the other applications. This is a small example. This slide is already here about configuration, import configuration InfraWorks. As I suppose everybody here knows, you have the data objects like a Revit file, you import it there, and we establish a process to use 000 as our point of reference. So we don't need to play with coordinates to put our models in InfraWorks. We're going to show exactly that way, and I had a video that works. So that's one of the situations. A lot of people complain, they try to drag objects inside the InfraWorks and never land. In UK, we had a lot of cases where the stuff land in north of Atlantic and things like that. So if we do a good preparation and good coordination between our Civil 3D model and our Revit model, when we created Revit assets, they're going to land smoothly there. For that purpose, Lucy, this is yours.
Just a couple of notes. When we are using InfraWorks, when we bring in data, you can have that data from the disparate data sources. You can have it processed on the cloud. If you want to speed things up, you can also process it on your local machine if you have a copy of Navisworks Managed. It has to be the same year. If we're in 2018, you have to have Navisworks Managed 2018. So that will do that calculation a little bit faster than we'll do it locally. So that's number one. And there's a check mark in the application settings in InfraWorks that you should look for, and it's under data import. The next thing, this is amazing, that when you do placement of 3D models, that you have to do it in XY international feet, no matter what the units are. And I don't know why that's that way.
It's because the Revit model inside is international fits. But it's one by one, so there is no scale, no factor there, it's okay. But the model comes in its origin as a international.
Any model you bring in. If I bring in a metric 3D solid from AutoCAD, I've got to do it this way. All right, and then also, when we're dealing with these very large coordinate offsets, just use Notepad to copy clip over so you don't, do some mistakes in typing.
So this is your flyover. You had your video here? Can you run this?
Yeah.
Yeah, open it. It's easier. Open directly.
Got it. So just, if you take our data set and put it all together, 1, 2, 3, then you'll end up with something that's simple, but it gets the point across. These objects if you set up the base coordinate system in Revit, the survey point correctly, you literally can drag and drop the Revit files into the canvas, into the InfraWorks canvas. We know we can do that with shape files and other content, but I bet you didn't know that you can drag and drop Revit in. You still need to configure it, but you can drag and drop it.
So let's go to my part. So as Lucy established our project in Civil 3D, I start to establish my project in Revit. So I create, I will show the file itself. So we create a big zone of interest. We call it the base project file, let's say, and where we can establish the coordinate with our GIS information. And then we start to link Revit files there. So we had 3 methods, and that's what we're going to talk today, about how to link Revit models in our big project. We had individual projects already developed, and we had assemblies of groups of buildings that are also created. Another point to notice is how we can connect these tools, what works and what doesn't work. So never forget that we had some workflows at work. I proposed to talk about Dynamo today, but I saw a lot of nice Dynamo classes around that were much more extensive here. And the Dynamo here is only to push data from Civil 3D automatically inside Revit. It's things we are doing can be speed up if we use Dynamo. Okay. Sorry? That's okay. Okay, that's the hard part. How are we going to establish shared coordinates between Civil 3D and Revit models? With Revit 2018, it's a little easy because the acquired coordinate system works much better. So for that purpose, Lucy in Civil 3D create a point, an object in 3D that's on the survey point. At the same time, she's going to create a very small piece of drawing where she's going to establish the GIS coordinates. And that small piece of drawing, a block, that's what we call the placeholder. We want to use it to bring the coordinates to all our models. So if I had a project already developed in Revit, I can bring this placeholder, place on the correct point, and acquire the coordinates. So let's continue here. This is an example, so don't forget some objects. If I want something visible in Revit, it should be a 3D solid in the AutoCAD. Use the coordinate zone assigned, proxy graphics server 1, and create a small double block with origin at 0, 0, 0. So in Revit, this data is the one extracted from the AutoCAD file. Again, a repetition of the information I had before. And okay, my videos works. So here I start. I had a base template where I'm going to create my big project file. This base template is 0, 0, is from the box. I'm going to link the small DWG that bring the properties, the GIS properties, to the project. I use the normal, I'm going to use manual, so to be sure that I grab the object and I put it where I want, and it doesn't go nowhere else. I haven't cut the video, so we're going to wait for the file to load. These are the typical questions, warnings that we get in Revit. They are not important here. And this is the file that I bring from Civil 3D. I don't know if you want to explain anything about creating this file. And then I move it, align it, and place it there, and I'm going to acquire coordinates. So this is going to establish my project-based file with the right GIS connection to the Civil 3D and to the InfraWorks project. So the normal process, I place it there, acquire coordinates, and it's going to establish. So I show here that we go to properties. We can see the objects there. And somewhere we're going to see that the properties, the dimension, the distance here match the information that came from AutoCAD. So I had a project-based file to start. Okay? So I go to the next slide. Okay. Now I want to link the master plan that is made in Civil 3D. And this time is quicker, so I only need to link by shared coordinates. I already acquired the coordinates, it's all matching, and now I had the big master plan, the big DWG file, that I'm going to bring it here. So again, select the point to check the coordinates are correct, link file. And by the way, since last week, I have done this in the cloud using C4R. So I can link DWGs from the cloud now. And IFCs and other stuff. So it's loading the file. I hadn't cut, but my videos work. Come on. Stuck there. Okay. And this is the file. I made a small request to my friendly engineer, and she put me some points of interest there with the vector distance from the survey point. And you see why we use this. In some situations, could be necessary to displace in InfraWorks the object, so we can use this reference. So if we measure there, I get the real coordinates of that point. If I change the family, I can change these and create a family that's going to read the distance from the survey point. Basically, it's changing the tag in Revit. So it's a normal tag that measures the information, that gives me some information. So this is the family for spot coordinates, and is measuring from the survey point. So I'm going to change from the project point, and I'm going to have the offset on the points that I'm tagging. Okay? And these match the data that came from Civil 3D. So everything is spot on, everything is matching. Okay, let's go to another one. Now I need to start work. And what I can do, I can create an empty file, extract it from this place, to give it to one of my colleagues to start create a new project, a new component of Revit. And in this case, I want to do a study for a bus stop on that intersection there. So what I do, I go to my master plan file. This is my established point. I'm going to create some information here. I'm going to draw grids to create an axis, two axes. Right now, I put it manually. I'm going to line them through the property lines I have there. I can design other things, rename. That's a question of organization. I'm going to draw a small polygon to add an idea of my emplacement. And what I'm going to do after? Who are Revit users here? They don't know what to do? I hope so. Well, we're going to select that object, create a group, and generate a link file. And apply the coordinates to that link file. And that file, I give it to my colleague that continue to work on a base file that correctly land in my project in the future. That's one of the solutions we had to keep consistency and connection. So I'm creating the group. I should isolate a little the video. Saving the group. The group is there. I can check. I'm publishing the coordinates to the group and saving it. Save it again. I'm going to open it. And I see an empty file with my coordinate point, reference point there. That's correctly what I want to start a new project already connected to my base project. Okay? I'm going to close this because it's a repetition. A different one, I had a project already created, and I want to put it in my environment. So I had this small house here. It was used in another study before, so we had some coordinates that are not the ones of my project. So I want to establish a new coordinate system. Be careful if we had site properties already established. We should work by default with the new ones, because if not later when we insert to InfraWorks, you're going to land on the old coordinate system. If we had objects with multiple site properties, we need to be careful on that. I had a slide showing that part. So this is okay. I'm going to manually drag it, put it there, and then do some adjustments. Sometimes we can do it, but we need to be careful. Because in this case, as I used this model before, he had his own coordinate system. So you go to the site option, and you see more than one system there. So we need to remove the old ones if we don't need them, or make current this actual one that we're going to push. So, okay, this is align, move, rotate, put where we want, change the elevation, create scope boxes so we can control the visibility of our objects. Very mandatory in these big projects. Use a lot of scope boxes, associate views to the scope boxes, and manage the visibility of the scope boxes. I don't want to drive around the model looking for my objects. So we create views, we name the views for the different entities, and that way we can manage our model. It's a huge model. If I go zoom, 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 you're going to see. I had some videos where some of the parts I forget this part, and I need to jump around looking for it. So, okay, the model is there, it's not yet correctly positioned. This is the floor that I created before on that small file that I created rectangle. It was for a study for a bus stop. And this is my model, so I'm gonna speed up. I'm gonna move it on 3D or what I had. I don't have nothing more there, but it's already on the right spot. Okay, let's go to the next one. So the next one is continuity. So the model is there, we want to adjust. So again, as I was explaining. On this one, we're going to show how to create a scope box, make a section, or make an elevation oriented by the scope box. So that way, we're going to work in that small environment instead of working in the normal views of a big project. So I'm creating the scope box, then I'm going to create an elevation, associate elevation there, and go on with this. Typical problem. It's huge. It's so far away, we cannot find it. I hope everybody knows that if we had the scope box associated to a plan view, and we say this plan view is related with the scope box, we can generate a 3D view and go to the 3D view and say orient to a view. And that way, the limits of the 3D view is going to be the same limits of the plan view. That is, its boundaries are the scope box. This is also very, very easy to use, and it's very important. So if I want to cut that part, I generate a plan view, I duplicate the plan view and say, okay, my plan view is going to be contained by that scope box. And then I'm going to do the same for the 3D view. So I had plan views, 3D views, sections views, they are all with the boundaries of the scope box for that zone of interest. Okay, this had the continuity of the process here. So I'm establishing the elevation view. I had no reference yet, so I'm not connected to a scope box. That's why it gave me much more trouble to review. Okay. And the extent of it was not yet associated with scope box. That's what I'm going to do now. I connect the elevation with scope box. And when I jump to the view, now it's showing the depth of the scope box. Then we can adjust, and in this case, I'm going to create a reference level, associate the reference level, and move my model to the reference level. Every time we move a linked file, you're going to give a message, say, you want to save the new coordinate placement to my model? Yes. And we always do that. So we are updating the linked file in terms of coordinates and positioning. I think I can go further. If not, we had no time for everything. And this is a different way where I had more complex model where I need to establish rotation. That's sometimes the other problem, how we rotate the model correctly so it can be. So on this model, I'm going to grab the small placeholder we have. I'm not establishing yet the position. Only start to acquire the coordinate system. That's what we're going to do. And then apply the rotation to north. For that, you need to be in Project North, in true north. Let's see. When we do true north, it rotates there. We change these. Okay. And because I had this drawing with these 3 vectors there, it's easy to me to know where is the north, the real north for the project. So I'm going to use that part there to give me the rotation. Okay? And in this case, if I want to establish a new position, and this double G, I need to rotate it again. Because when we apply the north, it stays on the same position. So a good practice sometimes is remove the double G and insert it again. And when we insert it, you're going to land correctly. So you're going to see, I'm going to insert a site model coming from Civil 3D with the contours to generate a surface. And when we do this object is going to land there. It's not with shared coordinates, so it was manually landing, but now I'm going to move through that point. I've made a mistake here on purpose. Probably guys that work with Revit understand why. So I've inserted this object, but it's a contour files with 3D contours. And I established as only on this view. So I cannot generate a surface. It's a flat file. Because I want to create a site model in Revit with a topo surface, I'm going to remove it, insert it again, but this time visible in all views. There is a set box when you insert. That's why the handouts are not ready, because we want to explain the documentation, document all these videos with more detail. So this is a plant treatment tank. And when you see, now I can create the surface, the topo surface from the link file. Oh, this is even before. So I'm going to accelerate a little more. So what I'm going to do, I'm going to remove it again, insert it again, and next time I select it, so I'm going to insert now. So check only it's important to know all these properties here, current view only. If we do that, the double G is inserted as a flat view on the view that we are active working. If we remove it, it's going to be a 3D object that's going to be visible in all views, unless we hide on the properties, of course. That's a big difference when we import, when we link a Revit file. A DWG file in our Revit model. Okay, it's done. And now it's going to create the topo surface. We select the layers that contain the contours. And the surface is there. And this surface, we can also send it to InfraWorks, and they're going to land on the right spot. Send it to Navisworks, put it on glue. It's connected with our project. Okay, I'm going to further select this. So now we had another phase. Lucy have developed a lot of things in Civil 3D that we want to see as solids in Revit, like the sewage system, supplies, utilities, a lot of components of Civil 3D. So we want a way to bring them to Revit. So I request Lucy to do it. Can you open this video? You know which one it is? And explain the process from yourself. Yeah, probably that's it. No, that's, no, open there. Check if that's done. Yeah. You want to explain?
Very dynamic BIM tool to do not only the roadway but also the grading. Here's, when we're dealing with Revit, when we do the corridor solids extraction, you must toggle in to take them out as color by layer. If you don't, they're not going to be able to be labeled and attributed adequately in Revit. So that's just a thing to remember. That's something to jot down that's not documented anywhere, that you need to do that as not by color, but by layer. And here, once we bring this out, here's the trick. Anything that you want to bring into Revit, I'm doing a right block. I'm taking this out, and I'm taking it out at its coordinates, where it was actually, where it lands in the real world. So I'm separating this piece out, but it's still in the real world. And then that right block, I'm going to simply open it up, and that square solid that is the origin of the Revit survey point, I'm just going to insert that. And so now I have our piece in the real world, and it's connected to the Revit survey point by this little tiny square, and it has to be a solid, and it has to be in 3D. And once you have that, now you're setting yourself up so that that data can be used easily in InfraWorks and in Revit. Okay, so you don't have to do any moving and adjusting. Keep it at its normal coordinates, but just make sure you get that solid square inserted in. And when you insert it, don't move it. Keep it at its original place. And then you're going to be guaranteed success with this. So if we had a moment for the materials.
I want to show now the family in Revit.
Yeah,
doing
okay,
this.
Okay, do that,
Okay.
and then we're about done.
Yeah. So now I'm going to show what I'm going to do in Revit. So why we look for this process to do it this way? As probably most of you know, if you link a Civil 3D file with lines, with the surfaces or something like that, you cannot cut it. So in a section you don't see the object, is not cut it. On the other way, if we link it once and we had repeated objects, so for instance, light poles or components from sewage systems, sometimes we need to repeat them. It doesn't mean that we want to place it once. So what we're going to do, we're going to create a family in Revit. And it's a family in a category. In this case, we're going to use the site category. The families don't recognize coordinates. So what we're going to do, we're going to use the insertion point of the family that's in our template, and we're going to grab the file that will create that surface, put it there, and align the origin of the family, or of the block, with the center of our family, with that insertion point of our family. You're going to see it, so it's a very easy process. Grab the file, insert. Here I'm going to do manually. There is no current view only. It's a solid object. I want to see it in 3D. There is no issues with scale. Everything is smooth. Go, manually, origin, put it there. Sometimes I use center. It's more sure. We never know where the origin came from. So the file is there somewhere. It's loading. And we're going to see it. And we do a zoom extend, and we're going to see that part of the surface somewhere on our screen. Okay? And if you notice, we zoom there is a small cube that I ask Lucy, please insert this object in your origin of your family. This is a big helper for me. And with this cube, I can move it, all the object, and align it on the origin of my family. So now I think everybody's going to guess. When I insert this family, I'm going to pick what? My survey point in my Revit project. So this surface is going to land with the same offset that I had in Civil 3D, because we work with the same survey point. I'm not using project-based points here. Survey point and is my reference for all the things. Okay? That's sometimes some confusion. Project-based point is more when we are integrating multiple Revit files. But to integrate the survey file, the external files from AutoCAD to our project, we should establish a survey point inside our project space, and not something in 3,000 kilometers away that's going to create troubles, objects came skewed, and stuff like that. So you see now, I'm loading the family, I'm going to pick that point there. So after it's done, we're going to see a view. Again, they haven't established everything correctly. So family is there. No. Okay, family, component, somewhere. Oh, awesome. I know what. I was looking for the right file. I make the video with two files at the same time in the background, and I miss up which one was the correct one. So let me do it again, cancel, and now load the file. These are practices that could be accelerated with Dynamo, where we can use Dynamo to accelerate this process. I don't have the script for this, but we can develop it. It's not something very complex. And that way the family is going to be inserted. We can add a script, extract the families, and insert all the families at the same time. And all the families are going to be all the components that came from Civil 3D. Lucia gave me this main surface, but I had the road, pavement, I had the curbs, I had the bicycle path, everything is there. So I'm bringing these components from Revit. I can bring a roundabout, the subcomponents of a roundabout as solids piece by piece and put it here. Sometimes the roads we can make the intersections. We don't need to bring the full road like we had in this project. So it could look sometimes a little crazy why we do this, but it's the only way to be able to have this kind of BIM components in an environment outside the Civil 3D. Okay, now we had another thing, very common. I'm architect, I'm working in my project, and I need to ask the civil engineer to work in my terrain. And this is always the fight. When I change my model, I'm going to request the civil engineer to do the changes. And in this case, I'm going to ask the civil engineer. So in my model, I found that I need to create a ramp for access this garage there. So I make small views. I'm going to save them as DWGs and send it to my civil engineer. I know not worried with a lot of information. Anyhow, the small DWGs I'm going to send, they are also coordinated by the survey point. So when Lucy brings to her project, they'll land on the right spot. And these are reference information. It's like an annotation. I can do this if I use C4, I can do this in BIM team, make an annotation, put some notes and send to my colleagues there. But we are not talking on this today. So I want a ramp to access this project here. This garage here. This is my main model. So I create two free views, a section, an elevation, something like that, and a plan view. This situation that I want to establish there. I want to remove the terrain and create a ramp. So I was checking if everything is OK. By the way, here the model is more complete. I already had the sewage treatment systems and all there. OK, as you see, my original surface, the file that we insert before, was covering that zone there. And that's what we want to update. OK, so let's go to the next slide. I send it to Lucy. And of course, she have made her work. She created a new surface with ramps and all that part. So what's she going to do? She's going to give me another surface file that I insert in my family, save the family as surface number 2, and switch the surface. So I came to Revit. You're going to see here. The terrain is still the original, but I had another family. So I switched the family, and I get the ramps in Revit. Right? So I had a new version of my file with an update that I request to my civil engineer. This was a very simple example, but we can do this with a big site placement with a lot of houses to connect, small roads. I'm not the guy that draws the roads, right? I need to ask a civil engineer to develop it. And this is a process that's very common. It's always a request. Can we change the models between Civil 3D and Revit? We cannot. So we need to find ways. And this is one of the ways to move the data between both platforms. Yeah, it's almost end. Now we go to the InfraWorks part. So how we land these objects in InfraWorks. So this is one of my models, detached from the central project, so I can treat them one by one. And this is the point I want to show. In this file, because it was used in the past, I have 2 site locations. Be careful, because if the default site location is not my actual, the model never lands on my right place in InfraWorks, because InfraWorks is going to read this information. That's why the model yesterday was out of the space. OK. It's done? No, it's running here. Yeah, it's safe. We can go. So we go to InfoWorks. We drag the model there. I already have the platform of the bus there. I think everybody works in InfoWorks, right? So they know how to do it. And if you notice here, I only check the British National Grids. Everything is 0. I don't need to change nothing. And it's creating the model. Let's accelerate this a little. Processing, okay, check, all 0. Yeah. Okay, this is the building, before was the platform. Yeah, that's why I'm showing. I clean everything to 0. Zero and not empty. It was not working there. And there it is. So the small house I was testing, the main building I was testing, 0, 0, 0, everything moves smooth. Okay, let's jump another one. We don't have the federated model in Navisworks. You want to show the fly-through on InfoWorks? Wait, 2 minutes. If you want to show the fly-through, the final model in InfoWorks. If not, we can wrap up. Any question about the process? It was clear, not clear? As I say, we're gonna the PowerPoint itself gonna be published quickly, but the handout itself we're gonna create articles and we're gonna publish. So we're gonna try send links to you guys who had we had access to your information, so you can receive a message with the links for this process. And thanks a lot for your presence here. Thank you.